Thanks, James. So, let's have a look at a visual representation of what we've just been discussing. So here, in front of me, I have two identical syringes. And these two identical syringes are going to contain identical dosages or quantities of the solute. And what I'm going to do is I'm going to put 1 gram or 1000 milligrams of solute into them. What I've also got in front of me is two containers. This one, which contains 10,000 mils of solvent, and this one that contains 1000 mils of solvent. And what I'm going to do is I'm going to place these equal quantities, 1000 milligrams, into these two containers, and we're going to have a little look and see what happens. Now you are going to have to use a little bit of imagination because there is some magicking going off to the side of the screen here, but let's see how it goes. So let's take our first syringe with 1000 milligrams in it, and let's place it into the 1000 mils and see what happens. Okay, next, let's take our same dose, our 1000 milligrams or 1 gram, and place it into the 10,000 mil of solvent container. Oh dear. So what we can see is that when we've added our 1000 milligrams to the 1000 mil of solvent, we can see that this one, hopefully we can see that this one is a lot more concentrated compared to this one, which is a lot more dilute. Now we've put in exactly the same quantities of the drug or the dosage of the drug, but we can see how the ratios are different and the dilutions are different. So if we take this one, for example, into 1000 equal parts, we would end up with 0.1 milligrams per milliliter. And similarly for this one, if we split this into 1000 equal parts, we would have 1 milligram per milliliter. And we can apply exactly the same principles to our adrenaline 1 in 1000 and 1 in 10,000. Now, what I'm going to do is I'm going to repeat this experiment, except I'm going to be using slightly different quantities in slightly different ratios in a slightly larger glass. Back to you.